This is the fifth FRQ from the 2013 AB exam, and the bummer about this problem is that since it's the fifth FRQ, there's no calculator use allowed on it. So we're going to go ahead and find the area of R, and if I look at this, I can see that that's going to be an x value of 0. There's my x value of 2, so to find the area, I'm going to have to do the integral from 0 to 2 of the top curve minus the bottom curve, and I just have to figure out which one is which. So this is a parabola that's right side up, so that's got to be this one. And then cos, which fits, right, because a typical cos graph looks like this, and so that fits, you know, there's some transformations on it, but it's got that general starting shape. All right, so we have from 0 to 2, we're going to do top minus bottom. So we're going to have 4 cos. Instead of 1/4 pi, I'm going to go ahead and just write pi fourths. Pi fourths x minus the bottom. And I can see that for this part, I'm going to end up using u substitution. For this part, I don't really need to. So I'm just going to go ahead and kind of split these integrals apart. So I'll figure out my u substitution in a second. And then I'm just going to go ahead and subtract off the integral from 0 to 2. 2x squared minus 6x plus 4. The nice part about doing this is I don't have to worry about distributing that negative because I'm just going to get a number answer here and know that I'm subtracting it. Okay, so for this part, I'm going to say that my u is pi fourths x. The derivative of that is pi fourths dx. I do not have a pi fourths sitting in the front, so I'm going to divide, well, I could multiply by 4 over pi to get it over to the other side. So 4 over pi du equals dx. And so what that means is that I could pull out the 4 from the original problem, and then I'm also pulling out the 4 over pi that I just got. And so that means that I'm actually, I'll just write it like this, pulling out a 4 and a 4 over pi. That's cos u du. Now, if you like to take your interval and convert it so it's in terms of u, and you can just finish that part of the problem in terms of u, you can do that. Or you can do this, get it back in terms of x and plug the numbers back in. So if you're going to like return it into the x coordinate, return it, did you like that? Then you should not put 0, 2 here because the 0, 2 is in terms of x, it is not in terms of u. I'm going to go ahead and just convert it into u and finish that part of the problem with u's. So I'm going to say the function, if I'm plugging in 2 for x, I get pi fourths times 2, which is 2 pi fourths, which is pi halves. And then if I plug in 0, I get pi fourths times 0, which is just 0. So this is, I've converted everything to u. All right, so the antiderivative of cos is sine. So I have 16 over pi times sine u evaluated from 0 to pi halves. And I'll just go ahead and finish that part. So 16 over pi times sine of pi halves minus sine of 0. Pi halves is up here, 0 is over there. So we've got 1, 0, 0, 1. So we've got 16 over pi, and then that's 1. 1 minus 0 is 1. So we got 16 over pi. Okay. Over here on this side, we've got 2/3 x to the third. 6 divided by 2 is 3, minus 3x squared plus 4x evaluated from 0 to 2. So when I plug the 2's in, if I plug 0 in, I'm just going to get 0 for everything. 2/3 times 8, 3 times 4. So we're minusing 16/3 minus 4. So this is -4, that's minus 12 thirds. So we've got 16 over pi minus 6 minus 12 is 4, minus 4 thirds. Now, just remember, you should have been able to leave it probably right here, or maybe evaluating these to get those. Not this, you could have left that there, but maybe evaluate those. Okay, so that's the answer for part A. That's the area between the two. Part B says to write, but do not evaluate, the integral that gives the volume of the solid generated when r is rotated about the horizontal line y equals 4. So if we put a horizontal line in here, there's the horizontal line. And so if we rotate that, that's the washer method. We've got space in between. So I'm going to go ahead and do B up here. So that means we're going to have big R and we're going to have little r. And big R, they're always top minus bottom. And big R is the one that's got the furthest radius. So top minus bottom. Little r, top minus bottom. And then for our integral, we're going to have pi big R squared minus pi little r squared. I'm going to go ahead and take the pi out to the very front. So I have the integral from 0 to 2. And then I have 4 minus f of x squared minus 4 minus g of x squared. So we got big R squared minus little r squared dx. And since you did not have to evaluate it, that part's done, which is kind of nice. Okay. Part C. We're talking about cross sections. They're perpendicular to the x-axis. That's great. That means it's in terms of x. They say that we are making squares. So first I want to know what the slice is. And the slice is going to be top minus bottom. So g of x minus f of x. And then for a square, we do, maybe I was saying slice every time, but maybe it's s for side of the slice. Anyway, it's side times side, so that's s squared. And so the integral is going to be from 0 to 2 of g of x minus f of x squared dx.